Aloha, we're going to look at part one in our fraction games, adding and subtracting mixed numbers like related, unrelated denominators. And to do that, we will review some of our fraction basics. To do that, we're going to visit a site called LearnZillion. And this site has a ton of awesome mini lessons. And I chose a few to get us started today. Again, the site is LearnZillion. And we're looking at adding fractions with unlike denominators using a fraction bar.
How do you add fractions with unlike denominators? For example, what is 1/2 plus 1/3? In this lesson, you will learn how to add fractions with unlike denominators by using fraction bars. Let's start with a little review. We know that fractions need to have the same denominator to add them. I remember that my teacher called this a common denominator. I also know that I can use equivalent fractions to make common denominators. We know that equivalent fractions show equal amounts. Here you can see that both equivalent and equal have the root equi, which means equal. So here's an example. 1/2 is equal to 2/4, which is equal to 3/6, which is equal to 4/8, which is equal to 5/10, which is equal to 6/12. All of those are equivalent fractions. This could go on forever. So the question is, how do I decide which equivalent fractions to use? We also know that when one denominator is a divisor of the other, only one fraction has to be changed. So here we have a problem, 1/2 plus 1/8. 2 is a divisor of 8. So I'm going to make an equivalent fraction for 1/2. And I'm going to start by dividing each of my pieces in half, then those pieces in half again to form 8 pieces. And now I can see that I have 4/8. 4/8 plus 1/8 is ready to be added because they have a common denominator. And I can see that that makes 5/8. Here's another situation we've encountered before. When both denominators are multiples of 10, only one fraction has to be changed. For example, in 1/10 plus 3/100ths, I know that 1/10 is equivalent to 10/100ths. So I'm going to go ahead and put that in as my equivalent fraction. And now I'm ready to add because they both have the same denominator. 10/100ths plus 3/100ths is 13/100ths. A common misunderstanding happens when students begin to add without forming a common denominator. I've seen this happen a lot, where they're thinking very hard and they say, 1/2 plus 1/3, that must be 2/5. And they add the numerators and they add the denominators without thinking about what each of those things means. You can see here, if I were to add a half and I were to add a third, it's going to be much larger than 2/5. So let's see how we need to do this. Let's return to our original problem. What is 1/2 plus 1/3? Well, one denominator is not a divisor of the other, and neither denominator is a multiple of 10. So I can multiply any number by 1 without changing its value. I could use that to form some equivalents maybe. But how do I decide which equivalent fractions to form? Well, here's what we need to do. Look at the denominator of the other fraction to decide what number to use to make the equivalent fraction. So here I have 1/2 plus 1/3. In order to make my equivalent for 1/2, I'm going to look at 1/3. And I'm actually going to multiply by 3/3 because the denominator is 3. I'm going to use 3 to multiply my half. I write this with a 1 around it to remind me that I'm allowed to do this since 3/3 is equal to 1, and I can multiply by 1 without changing the value. When I multiply by 3/3, what is happening is that I'm actually dividing each part of the whole by 3. So when I do this on the fraction bar, you can see the 1/2, those pieces have been divided into thirds, as well as the other side. And that gives me its equivalent, which is 3/6. You can see that that multiplies the pieces by 3, and now we have 3/6. So we have our equivalent for 1/2, it equals 3/6. Let's do this again by looking at the denominator of the other fraction for our second fraction. So for 1/3, we're going to look at the denominator of 1/2, which is 2. So 1/3 is going to multiply by 2 over 2. Again, I'm going to draw a 1 around it to remind me that I'm multiplying by 1. And you can see that this is going to divide each part of the whole by 2. So each of these pieces is divided in half. And that gives us an equivalent of 2/6 because it multiplies the pieces by 2. So now I have 3/6 plus 2/6. Now I can add 3/6 plus 2/6. Let's move our pieces. We've got 3/6 and 2/6 is equal to 5/6. Let's try another one. Sammy says that 1/3 plus 2/4 is 3/7. But Trevan says it adds up to 10/12. Who do you think is right? Well, let's take a look at it. What is 1/3 plus 2/4? Here we have a third and we have 2/4. We know that one denominator is not a multiple of the other, and neither denominator is a multiple of 10. I know I can multiply any number by 1 without changing its value. So how do I decide which equivalent fractions to use? Well, I think I need to look at the denominator of the other fraction again. So when I'm going to look at 1/3, I need to look at the denominator for 2/4. So I have 1/3 times 4 over 4. I like to write my 1 around it again. And that shows me I'm going to divide these pieces, each part of the whole, by 4. So I divide that one by 4, divide this one into 4, this one into 4, which multiplies our pieces by 4. And we get 4/12. Now we're going to do the same thing with the other side with our 2/4. So we're going to look at 1/3 and use the denominator, which is 3. So we're going to multiply by 3/3, which means I need to divide each of the pieces by 3. So here I've shown you they're drawn into thirds, each one of those. And that in turn multiplies our pieces by 3 and gives us 6/12. Now I can add because we have a common denominator. We have 4/12 plus 6/12. Here's our 4/12 and our 6/12, which is equal to 10/12. Trevan was correct because 1/3 plus 2/4 is equal to 10/12. In this lesson, you have learned how to add fractions with unlike denominators by using fraction bars.
Awesome. I hope that was a nice little refresh for you. Okay, again, that site was LearnZillion. In the challenge question this week, we're going to look at the ancient Egyptians, okay? And it says the ancient Egyptians used unit fractions, such as 1/2 and 1/3, to represent all fractions. For example, they might write the number 2/3 as 1/2 plus 1/6. We often think of 2/3 as 1/3 plus 1/3, but the ancient Egyptians would not write it this way because they didn't use the same unit fraction twice. Try this. Write each of the following Egyptian fractions as a single fraction. So for number 1, it was 1/2 plus 1/3. And you're going to be writing each of the following Egyptian fractions as a single fraction. So what would 1/2 plus 1/3 be? Using the strategies you saw in the video, try these out. Pause the video, and for number 1, the answer is given, but I want you to try to solve and see if you come up with that answer to check your understanding. Once you're done solving the 3 problems, move on to the next question of the video. All right, so you tried to work the first 3 problems to check your understanding. Now here's something. How might the ancient Egyptians have written the fraction we write as 3/4? How might they do that? I'm going to go back up here and we're going to look at what we were shown earlier And what you could draw with your unit fractions is something just like this and continue on. It's almost like a fraction fringe, which we've used to help us visualize the representation of our different unit fractions. Okay, so it's almost like if I'm doing a bar model of a unit whole, and you'll start off at the top, like here, where they're doing a half, and then they broke it up into different parts. Okay, so you want to check out how you might write 3/4.